In this video, I'm going to work on page 1 of the work problems. And page 1 starts with 2 warm-up questions where you're supposed to solve equations. So I'm going to zoom in on part A. So first thing I want to look for, because this is a rational equation, I want to look to see if I have any domain restrictions. So I'm going to look at my denominators. I can't make 3 equal to 0. I can't make 5 equal to 0, but I can make x equal to 0. So I'm going to put off to the side, my domain restriction is that x cannot equal 0. Now, second thing I want to find is my LCD. Now, my LCD could be a lot of different things, but I'd like to keep it as small as possible. And what I want to do is use all 3 of these factors. So 3 is a factor, 5 is a factor, x is a factor, and I'm going to use the LCD of 15x. And I'm going to take that 15x and I'm going to multiply it times every single one of these fractions. Now, in the first fraction, I can take 3 and divide it into 15 5 times. So I would have 2 times 5x. Plus, my second fraction, I could take 5, divide it into 15 3 times. So I would have 4 times 3x equals, in the third fraction, the x's will cancel out. So I would have 6 times 15. All right, let's see. 2 times 5x is going to be 10x. 4 times 3 is 12x there. And let's see, 6 times 15, I feel like that's 90, but I want to double check. So I grabbed a calculator. It is 90. All right, so 10x plus 12x is 22x. Set that equal to 90. I'm going to divide by 22 on both sides. And I'm going to get x is equal to whatever 90 divided by 22 is. I'm going to go ahead and let's see what fraction that is. So 45 over 11, which is also 4.09 repeating. My preference is actually the fraction, but if you gave me the decimal, unless the direction said otherwise, I wouldn't argue with it too hard. So that's part A. And of course, this answer of 45 over 11 or 4.0109 repeating is not my domain restriction, so I can go ahead and let that be the answer. All right, sliding over to part B. Part B, same kind of problem. I want to start by looking at my denominators. So I've got 5 here and 10 here. Neither one of those can be made equal to 0, so there are no domain restrictions in this problem. I would like to get rid of my denominators though. So my LCD, the LCD is actually 10. Now you could take 5 times 10 and use 50. Your numbers would just be bigger to work with, but that would work out just fine as well. So I'm going to take all these bits, parts, and pieces, and I'm going to multiply them all times 10. So let's see, in the first fraction here, 5 can go into 10 2 times. So I want to collect up all the pieces that are left. So I've got 2 times 4x plus the 10 and 10 will completely divide each other out, leaving just 7 times x plus 2. And then over here, I don't have a denominator to cancel out, so I have 10 times 20. So no more fractions anymore, but I do have an equation I need to solve. So 8x plus 7x plus 14 equals, is that 200? Yeah, that's 200. Let's see, 15x plus 14 equals 200. I'm going to go ahead and subtract 14 from both sides. And this right here is just solving with a regular linear equation. So let's see, 200 minus 14 is 186. I'm going to divide both sides by 15 here. Divide by 15. And I'm going to get x is equal to, now again, my preference is always an improper fraction or a fraction. Because then if the decimal is a repeating decimal, I don't have to worry about repeating or anything like that. This one is not too difficult of a decimal to work with. It's 12.4. So preference would be the 62 over 5. I would accept 12.4 again, unless the direction said otherwise. So those are the solving rational equations that we've been doing for a couple of days now. Now what we're going to get into are some work problems. And for work problems, you have 2 or more people that are working together to complete some amount of tasks. And the one thing that I want you to recognize, and I'm going to put this off to the side here, is we're going to constantly be talking about rate. And when we talk about rate, it's jobs over time. So your rate is the amount of jobs you can complete at a certain amount of time. The faster you are, then the better your rate is. But again, that's not really going to be important in terms of speed. It's just knowing that when we talk about rate, it's jobs over time. All right. So in problem number 1, we have Cleo and we have Phil, and they're going to work together to do some total amount of jobs here. Now it says Cleo can paint a room in 8 hours. So Cleo's rate would be one job, that's one room, in 8 hours of time. Phil can paint the same room in 6 hours. So Phil's rate would be one room in 6 hours. If they paint the room together, how long would it take them to paint the room? So my total jobs here is one room. And what I want to do is take each of their rates and multiply it times how long it would take them to paint the room. Now, I don't know how long it's going to take, so I'm going to say X for Cleo plus X for Phil. So now I've created an equation that I can solve. So I'm going to clean it up just a little bit here, and I'm going to make this X over 8. So I took the 1 times the X here, just X, plus X over 6 equals 1. Now, I want to look to see if I have any domain restrictions. I have a denominator of 8 and a denominator of 6. I don't have any domain restrictions then. And what I do want to use, though, is my LCD to get rid of those fractions. So I'm going to zoom in on the equation just a touch more. LCD here is going to be 24. You could, again, take 8 times 6 and use 48. Your numbers would be a little bit larger, but as long as you use a common denominator, it doesn't necessarily have to be the least common denominator. So I'm going to use 24. So 8 goes into 24 3 times, so I have 3x, plus 6 goes into 24 4 times, so there's 4x. And then I'm going to take 24 times 1. So that's going to equal 24. Combining terms here, I'm going to just slide this over here to give myself some space. 3x and 4x makes 7x. That's going to equal 24. Divide both sides by 7. X is equal to. Now I'm going to do, on my calculator, 24 divided by 7. Now, this is a place where the directions will probably tell you to round to 2 or 3 decimal places. So this X is 3.43. There's a whole bunch more decimals after. I just rounded it off. And that is time in hours. Now, what did we just figure out? What we just figured out was that if Cleo and Phil work for 3.43 hours, almost 3.5 hours, they would be able to paint one room together. So working together is faster than either one of them by themselves. And so we set up this equation to figure out what it would do for them working together. So that's problem number 1, and that's a work problem. All right, number 2 here. Naisha owns a lawn service company. Currently, it takes her 50 hours a week to service all of her customers. To reduce the number of hours a week she needs to work, Naisha hires Shantice to help her. While Naisha was on vacation, Shantice was able to complete all the work in 60 hours. If they work together, how long will it take them to serve all the customers? Okay, so we have Naisha plus Shantice equals sum total, okay? Now, Naisha has a rate of, I'm going to say all of her customers is one job. I don't know how many customers she has, but it's the same group the whole time. And it takes her 50 hours. Shantice on her own is able to do the same amount of jobs in 60 hours. So total here is all of the customers. Again, I don't know how many that is, so I'm just going to call it one group of customers. And I don't know how long it's going to take them working together to service all of these customers. So I'm going to go ahead and say X for Nisha, X for Shantice, and go ahead and call it together, or add it together. So X over 50 plus X over 60 is equal to 1. I want my LCD here. My least common denominator for 50 and 60 is going to be 300. All right, so 50 goes into 300. I believe that should be 6 times. It is, so that's going to be 6x plus 60 goes into 300. I'm going to guess that's 5 times. I am correct. I'm grabbing a calculator and using it right now. So 5x is equal to 300. Again, I always run out of room with these, so I'm just going to slide it over here. 6x plus 5x is 11x is equal to 300. Divide both sides by 11. So divide 300 by 11. All right, 300 divided by 11. So x is equal to 27.27. I'm going to, for these problems, because I'm talking about time, I generally am okay with the decimals for time. In the directions, I will tell you rounded to 2 decimal places, or 3 if I'm preferring that. So 27.27, this is hours. So if these 2 people work together, it would only take them 27.27 hours to complete all of the jobs. Whereas if Naisha did on her own, it's 50 hours. Shantice on her own is 60 hours. So clearly working together is much faster. All right, I'm going to do one more question on this video, which is problem number 3. And then I'm going to cut the video and I will do a separate video for page 2. So problem number 3, you've got Jane, Paul, and Peter can finish painting the fence in 2 hours. Now this is a little bit different because in this case, I'm telling you Jane, Paul, Peter, they're my 3 people, okay? I would just use J, P, and P, except I don't want to confuse myself with the double P's. And this is going to equal a total here. Now it says they can finish painting the fence. Now I'm going to say that's one fence in 2 hours. So each one of them is going to get 2 hours of work time. Okay, that's how long it took them working together to get the job done. Now I want to check out and see if I can find their rates from the rest of the problem. So it says if Jane does the job alone, she can finish it in 5 hours. So the job was one fence and it takes her 5 hours. If Paul does the job alone, he can finish it in 6 hours. So Paul gets a rate of one fence, 6 hours. How long will it take Peter to finish the job alone? So Peter is one fence in, I don't know how many hours. That's what we're trying to figure out, okay? So I'm going to clean this up a little bit, simplify where I can. So 1/5 times 2 is 2/5. 1/6 times 2 is actually going to be 1/3 plus 2 over x is equal to 1. Now this is like the problem that we solved earlier in the warm-ups. So I want to acknowledge that I can't have x equal to 0, which really wouldn't make sense to say that it took Peter 0 hours to finish painting a fence. Was the fence already painted? Like, we don't know what that would mean. So the 0 doesn't make any sense. But if you did happen to get that as an answer, that, again, you just throw it out. LCD here is going to be 15x. I'm just kind of cheating on this one and saying 5 times 3 times x is 15x. So I'm going to take all of these pieces, and I do mean all of them, and multiply every single one times 15x. So let's see what can cancel. So 5 goes into 15 3 times. So I'm going to have 2 times 3x. 3 goes into 15 5 times. So it's going to be plus 1 times 5x. Plus the x here will cancel out the x here. So that's going to be 2 times 15 equals 1 times 15x. All right, let me do a little cleanup here. So there's going to be 6x. And when I say cleanup, I'm just distributing. So plus 5x plus 30 equals 15x. All right, so 6x plus 5x is 11x, plus 30 equals 15x. Go ahead and subtract 11x from both sides. And I'm going to move my answer over here. So this is going to be 30 equals 4x. I'm going to divide both sides by 4. So let's see, what is 30 divided by 4? That is 7.5. So if Peter had to paint the fence all by himself with nobody else helping him from start to finish, it would take him 7.5 hours. So in this case, we knew their working time together was 2 hours. So I gave every single person 2 hours to complete one fence. And then I filled in the rates for each one of them working individually. All right, so I'm going to close the video here with finishing page 1. If you have any questions,